Chapter 2 Exploring the Weather. What is lightning? Why does the temperature of the water in the ocean vary in different places? Why do storms sometimes travel from southwest to northeast when the wind seems to be blowing in the opposite direction? Ben Franklin wanted to understand what makes weather, and he looked for answers wherever and whenever he could. To learn more about weather, he paid attention to the wind, the clouds, the temperature of water and air, and the patterns of storms. He asked questions about what he saw, and then he did his best to answer them. Sometimes Franklin went to great trouble to watch the weather. On one famous occasion, he flew a kite into a storm to learn more about storms and lightning. Another time, in Maryland, he chased a whirlwind for miles on horseback. He tried to break the whirlwind with his whip until it moved out of reach into the branches of the trees. And while sailing across the Atlantic Ocean, he measured the temperature of the water every day. He even asked his friends to report on the weather in their home colonies for him. Franklin wasn't always able to answer his questions about the weather. Quite often, his answers were wrong. Many of his questions weren't answered until the 20th century and the invention of the satellite. It was only when people could see the Earth from space that they could see the huge weather patterns that affect our world. Even though he didn't always have the right answers, Franklin's questions were important in our understanding of weather. When investigating Franklin's questions, modern meteorologists, scientists who study the weather, have learned a great deal about how the weather works. Watching the weather. Take a sheet of paper and colored pencils and try to draw a cloud. Don't look out the window. Chances are, your cloud look like this. Most of the time we think of clouds as fluffy and white. Now look out the window or step outside. Do the clouds really look like your drawing? You may see fluffy, white clouds, but you may also notice long, streaky clouds, or even little scattered clouds. Maybe the sky is overcast and all you can see is a white or gray ceiling. Now take your paper and pencils outside and draw a picture of the sky. To do this, you'll have to observe many things. For instance, you'll have to notice which clouds are high and which are low. You'll have to notice all the different kinds of clouds and their locations and shapes. You'll also have to notice whether different clouds are different colors. There is a great deal to notice about the weather, and clouds are only one part of the story. Even without special instruments, you can notice many things. For instance, what is temperature? Is it hot? Comfortable? Cold? Jot down your answer to this question on your cloud drawing. Is it raining? Damp? Foggy? Dry? Jot this answer down too. How strong is the wind? And in what direction is it blowing? Watch the clouds in order to answer these questions. Now put arrows on your drawing to indicate the direction in which the wind is moving the clouds. Look at your drawing. By noticing the weather and putting your observations on paper, you have taken a big step toward understanding meteorology or the science of weather. Understanding the weather. When you step outside and notice the weather, you are really observing the mass of air that is in your region right now. As that mass of air is pushed aside by another mass, the weather changes. Meteorologists or scientists who study weather use both simple and sophisticated instruments to observe the process of change and to predict the kind of weather the next air mass will bring. Masses of air are affected by three important things. Where the air mass has come from. If it has come from the North Pole, the mass will probably be cold. Where the air mass has been on its journey to your neighborhood. If it has crossed the ocean, the mass will probably carry more water than if it had crossed the desert. Where the air mass is going, the direction of the wind is very important to the progress of weather systems. When air moves over warm parts of the earth, it picks up heat. When it moves over cold parts, it becomes colder. The movement and mixing of warm and cold air masses is an important part of the Earth's weather system. Meteorological instruments record information about the air mass around them. Some are able to detect changes as one air mass is pushed aside and another moves in. The instruments you will build are simple versions of instruments meteorologists use around the world. Building a weather station, wind vane, anemometer, weather tracking chart, barometer, hygrometer, rain catcher, thermometer. Build your own weather station to track the weather, as Ben Franklin did. Your eyes are an important tool for observation, but here is how to make 6 instruments that will help you observe and forecast the weather. With your weather instruments, you will be noticing relative changes, that is, changes that are compared to earlier changes. You will use the instruments to answer your questions like these. Is this afternoon hotter or colder than this morning? Thermometer. Does the air contain more water than yesterday? Hygrometer. How much water has fallen this month? Rain catcher. Is the wind picking up speed or slowing down? Anemometer. In what direction is the wind blowing? Wind vane. Has the air pressure increased or decreased? Barometer. You can start to track the movement of weather systems by observing changes in the air mass right over your head. Then, combine your own weather watching results with information about other locations. You can collect this information from the satellite pictures on television, the weather maps in the newspaper, and up-to-the-minute forecasts on the radio. That way you will be able to tell what kind of weather is on its way to your neighborhood. The weather station you are about to build will help you become a better weather watcher. If you decide you are very interested in meteorology, you will probably want to buy some commercially made weather instruments. You can also buy or borrow books about the weather. You may even want to get in touch with national and international weather services. The What's Next section at the end of this chapter will give you the information you need to continue learning about meteorology. Find a safe outdoor place for your weather station, a spot where you can set up all your instruments so that they will not be disturbed. Of course, since some of your instruments will not be waterproof, you will have to bring them indoors when it rains. Read this chapter and gather your materials. Now you are ready to build your own weather station. Measuring hot and cold. Thermometers are instruments that measure temperature, hot and cold. You already know the temperature is part of the weather. It tells you whether you should be wearing short sleeves, a jacket, or a warm coat. You probably also know that temperature can affect the weather. For instance, you're more likely to get snow in cold weather and thunderstorms in hot weather. Over most of the earth, temperatures change with the seasons. As our part of the earth tilts away from the sun, we get colder, and it is winter. When our part of the earth tilts toward the sun, we get warmer, and it is summer. Spring, winter, fall, summer. Sun. To read changes in temperature properly, you will need to buy a thermometer. But if you are interested in making your own thermometer, just to see how our thermometer works, here's how. Make it. Thermometer. Materials. Tap water, rubbing alcohol, caution, do not drink this. Clear narrow-necked plastic bottle, 11 ounce or 0.75 liter. Water bottles work well. Food coloring. Clear plastic drinking straw, modeling clay. Procedure. Number 1. Pour equal parts of tap water and rubbing alcohol into the bottle, filling it above 1/8 of the way up. Number 2. Add a few drops of food coloring and mix well. Number 3. Place the straw in the bottle. Caution, do not drink from the straw. Dip the straw into the water, but don't let it touch the bottom. Number 4. Seal the neck of the bottle with the modeling clay so that the straw stands upright. Hold your hands on the bottle and watch what happens to the liquid in the straw. Congratulations! You have built an alcohol thermometer. Like a store-bought thermometer, the chemicals you use in your thermometer expanded as they warmed up. The expanding alcohol no longer fits into the bottom of the bottle. So, as the alcohol expanded, it moved up the straw. If you have overheated your alcohol thermometer, the liquid would have poured out the top of the straw. Experiment with your thermometer. Does it register cold temperatures at certain times of day? Does the wind make the temperature colder? Do sunlight and shadow affect temperature? If your homemade thermometer can't give you the answers you need, use the thermometer you bought for more accurate readings. Measuring air pressure. Wind is the movement of air. Since air is invisible most of the time, you may think air isn't really anything at all. But if you're a runner or a bike rider, you know air is real. You can feel the air as you push your way through it. Like many other things, if you push on air, it squashes down. If there is no room for the air to squash outward, it will get packed tighter and tighter. Air pressure is the force exerted on the air in the atmosphere. The air will be under great pressure or force. Air blown into a balloon is under pressure. The more air you blow into the balloon, the more the air is packed inside the balloon's rubber skin. When you release the neck of the balloon, the air inside rushes out and returns to the lower pressure of the air in the rest of the room. High air pressure in the atmosphere acts like the high pressure air in the balloon. It always moves toward the lower pressure air. This movement is one of the most important causes of wind. A barometer is an instrument that measures changes in air pressure. An air mass under high pressure acts in certain ways. For instance, in the northern hemisphere, winds in a high pressure area travel clockwise or in the same direction as the hands of a clock and down in the center. High pressure air masses tend to bring sunny weather. Of course, if the high pressure air has traveled from the north, it may bring cold, sunny weather. An air mass that is under low pressure acts differently from an air mass under high pressure. First, in the southern hemisphere, winds travel counterclockwise, or in the opposite direction as the hands of a clock, and up in the center. When a low-pressure system moves in, you're likely to see overcast skies or rain. Although the wind in an air mass makes a big circle, the circle is so big you can't feel it from your spot on the ground. Look at the picture and you will see, for example, that in Delaware the wind seems to be coming from the west, whereas in Philadelphia it seems to be coming from the east. Do it. Discover air pressure. It may be hard for you to believe that air, which feels like nothing, can change the weather. If so, try this activity to prove to yourself how strong air really is. Materials: clear plastic drinking glass, tap water, index card big enough to cover the top of the glass. You must have access to a sink. Procedure: Number 1, fill the glass to the brim with tap water. Number 2, place the index card over the glass. Be sure the top of the glass is completely covered. Number 3, standing over the sink, hold the card against the glass as you turn the glass upside down. Number 4, let go of the card. Why didn't the water pour out of the glass? The water stayed in the glass because the air pressure against the card was stronger than gravity, or the force of attraction that causes objects to fall to the center of the earth, pulling the card down. After a while, though, water will soak into the card. The card will become too heavy, and gravity will overcome the air pressure. The card will fall off the glass, and the water will pour into the sink. Make it. Barometer. Is the air above us under high pressure or lower pressure than it was yesterday? Is the pressure changing fast? A barometer can give you the answers to these questions and help you predict weather changes. If the air pressure is falling, a low-pressure air mass is on its way. The wind moving over your area blows counterclockwise and rain may be coming. If the air pressure is rising, a high-pressure air mass is moving in and fair skies are likely. Materials: scissors, round balloon, wide-mouth glass jar, rubber band, plastic drinking straw, transparent tape, index card. Procedure: Number 1, cut off the neck of the balloon. Number 2, stretch the balloon around the jar very tightly, pulling the end of the balloon off to the side so the surface is flat. Wrap the rubber band around the balloon and jar to keep the balloon from slipping. Number 3, cut one end of the straw to form a point. Cut here. Number 4, with a small piece of tape, attach the uncut end of the straw to the center of the balloon. Number 5, push down lightly on the balloon and watch what happens to the end of the straw. By pushing down on the balloon, you imitate an increase in air pressure. Number 6, put your barometer in a safe place. It doesn't have to be outside. Tape the index card to the wall next to the barometer. The straw should come to about the middle of the card. Number 7, mark the card where the straw points. Write the date and time next to your mark. January 10th, 10 a.m. Greater air pressure creates greater pressure on your balloon. Like your finger pushing down on the balloon, high-pressure weather systems will make your arrow rise. By the position of the straw, you will be able to tell whether the air pressure is rising or falling. In order to know if the barometer is rising or falling, you'll need to keep track of the air pressure by marking the card every day. If you fill up the card, tape a second one to the first one. If you notice that your arrow is consistently rising over the course of a day or several days, you can predict that a high-pressure system is on the way. This means that fair skies are approaching. Measuring wind direction and speed. Wind, as you now know, is related to the movement of air from high pressure to low pressure areas. Without wind, weather systems would not move around the globe. To find out about weather strength and direction, meteorologists use special tools. You will build a wind vane, an instrument to gauge the direction of the wind. When you are measuring wind direction and speed in just one place, it's hard to see large wind patterns. But you can learn about large weather patterns from national newspapers or television. You can also communicate with friends in other areas by phone, fax, email, or even regular mail. By paying close attention, you may be able to see for yourself that winds travel clockwise around high-pressure areas and counterclockwise around low-pressure areas. Just by talking to friends in different colonies, Ben Franklin discovered that winds and storms do not move in the same direction. One night, Ben and his brother were planning to watch an eclipse of the moon at 9:00 p.m. Ben was in Philadelphia and his brother was in Boston. Ben was disappointed when a storm blew up in Philadelphia, blocking his view of the eclipse. Since the storm was accompanied by winds from the northeast, Ben was sure that his brother too had missed the beginning of the eclipse. But a letter from his brother told him that the storm did not arrive in Boston until well after the eclipse had begun. Ben asked friends in other colonies when they first sighted the storm. He found the beginning to be always later the farther northeastward. Although he didn't yet fully understand the circular motion of winds, Franklin was the first to realize that northeast storms begin in the southeast, a surprising and confusing discovery. Make it. Wind vane. A wind vane is a simple tool that tells you the direction of the wind. It can be helpful for predicting weather since most weather is carried by wind. Materials: pencil, index card, scissors, 2 hollow coffee stirrers, paperclip, ruler, pushpin, plastic drinking straw, modeling clay, sheet of plain paper, compass. Procedure. Number 1. Trace or draw the wind vane pattern onto the index card. Number 2. Cut out 2 pieces of the pattern. Number 3. Cut a slit at each end of the first stirrer. Insert the 2 pieces of the pattern into the slits to form an arrow, which is the vane. Number 4. To balance the vane, attach the paperclip to the end of the stirrer that is holding the point of the arrow. Number 5. Cut a 1.5 inch or 4 centimeter piece from the second stirrer. With the pushpin, attach this piece to the center of the first stirrer. Number 4. Push the straw into the modeling clay so it stands up straight. Number 7. Push the short stirrer into the straw so the vane moves freely. You now have a wind vane. 8. Set your wind vane on the sheet of paper. Use the compass to find north. Then mark off north, south, east, and west with a ruler. For more accuracy, you can also mark off northeast, northwest, southeast, and southwest. Your wind vane will tell you the direction in which the wind is traveling. For example, if the vane points north, the wind is traveling toward the north. You will be able to track the wind over time by recording your observations on the chart at the end of the chapter.